Hi, my name is Sai Harshvardhan Madana. Today we are going to do the ICP 4 for the deep learning. Coming to the ICP questions, we have got the source code, and we are going to add the convolution input layer with the features of 32 maps with the size of 3 by 3 and a rectifier activation function with a dropout layer at 20%. Here I have run the code uh, for the reference, but I will run the code again because it takes time, since epochs which I have added is more, I mean 2, before it is 20, it took more time when compared to now, and so I have reduced it. And here, as per the question asked, I have added convolution layer with the size of 32 with the, and 3 by 3 matrix size, and the input size has given with the padding same, and I have given activation as a ReLU function, and with the rectification function, and I have added the dropout layer of 0.2. These all are the things I have done in the model. The model which I have created is a sequential model. Here I have, what are the things which I have taken here is fix fixing the random seed for reproducibility, which what all these things on the code and the source code which you have given. And the X train and Y train with the with I have trained the inputs of the X train and Y train and X test and Y test. After that, I started adding these all of the inputs, and I have started adding these layers to get the good output. And then I have this is the output. This is the one convolution layer, and the next convolution layer you have asked is a 32 layer, 32 feature map with a size of 3 by 3, and with the same activation redo function. But we need to use a max pool layer with the size of 2 by 2. Coming to this, here you can see max pool layer of a size 2 by 2, and a convolution layer of 32 bit size, and a 3 by 3 function, and activation reload. All these things have added the function in the same way. I have written for next 64 feature map with the 3 by 2 3 by 3 size, and activation reload function at the dropout layer of 20%. See, here I have you can see that convolution layer with the 64 with the 3 by 2 size, and activation reload function, and dropout layer is 0.2, that is 20%. In the same way I have done for all these things. And here we need to add a convolution layer of 128 with a max pool layer of 0.2. In the next function, we have after doing this convolution, we need to flatten the layer. This is the thing, flatten the layer. I have added this function flatten for the to get the flatten layer. This is flatten means nothing but the complete layer n by n function, n by n size of image will be converted into single array, like I mean list like function, making it flat. And after that, I have there are to add a dropout of 20%. I have added a function 0.2% as a dropout, and then layers and this and the function we with 1024 units at the rectifier relay activation function, and the dropout layer of 20%. And then and the next function with the same these details I have added. After that, with the 512 activation reload, and I have added with the dropout with the 20%. After doing this, I have started compiling the model with the epochs of 2, and the with the delay decay for decay equal to I rate, which was 0.01 divided by epochs. Then I started compiling the model and printing the complete summary. After that, I have started fitting the model. Model is a model dot fit. In this function, I have given all the data which I got as a train test, X test and Y test with the validation data as a validation data with the epochs. All the details I have sent to this model, and I started fitting this model. And then I have printed the accuracy and saved to the disk. And with these details, I started finding the accuracy. Here, since the epochs were estimating, it gives a 28,000 out of 50,000, and the accuracy is being calculated. In the meanwhile, I'll go into the second program, which is predict the four images of the test data, and then print the actual label of four images to check if the model predicted correctly or not. Here what the program is, we need to print here the program is we need to print the four images, and we are going to do that in the for function using for loop with a range of 4, and I started iterate using iteration. I'm going to take the images of these images, and I'm going to plot these images and in the console, I mean in the output. And in the fourth in the third function, here printing those images, and to check the model is correctly or not, and just printing those things only was required for till here. And visualizing the loss and accuracy with the graphs history or history object. Here what with these details I'm going to plot a accuracy graph and loss graph and accuracy graph with the labels of loss and epoch, and with the title of model loss. And with these details I have started plotting the graphs. For this I'm going to run this program. This is the the accuracy is being calculated here. It is for every each and every epoch. These are the four images which I have used for the in the for loop, and iterated and printed the for prediction value 7, prediction value 2, prediction value 1, and prediction value 0. And all these four images were printed. And this is the output for the third question, that is a model accuracy with the x-axis as a epoch, and y-axis as accuracy, and model loss with the x-axis as a epoch and y-axis as a loss. These two things also have plotted. The result is 97% of accuracy we got. Coming to the bonus question is for the program question for the 2, using the same model dot same thing we have to do with the .h5 model. For this we are going to do same. The program for the bonus is the same thing which we have used before. And for the second program, the only extra thing which we are going to add here, add here is a .h5 model, save .mynst managed model .h5. This is what we got it in the charger. We have this is what we have asked for the ICP. And the dense layers, and after adding the dense layers, I have added this saving with the H5 model. For this along with the output which we got in the question 2, we are going to get one more file which is called minst.h5 model. For example, if I run this code, it will give the same output which it has given for the before. In the meanwhile, it will generate the same this particular file and saves here. These are the values which we have generated. This is and we got this particular file created. Coming to the program 1, it's still running. And the epoch 2 till now epoch 1 was run with 50,000 of 50,000, and now 50 and the epoch 2 is running. Once it is completed, we will get the result. Finally, we got the accuracy of a 42.31%. Before adding all these things,